You ready? Okay. We have a 16 inches 2019. You guys can hear how the fan is crazy, but but actually not just not both fans. It's just one of the fan that is going crazy. Show what the so one of the fan it's crazily loud. Um, s- okay, then it stopped working altogether. Okay, so this has already been taken apart because they had to replace the fan to see if that would solve the issue, but that did not solve the issue. So um, this one is the one that is super loud. This one is fine. See, yeah, this is fine, but this one here is super loud. So what you want to do is you want to head over to the fan control circuit section of the board. Uh, let's disconnect that and take the board out. So they replaced the fan, but the issue persisted. Obviously, that's to say because it's not an issue of the fan. So what we want to do, so on the board you have the right fan control and the left fan control. So we this is the right fan and this is the left fan. So we will have to head over to the section of the fans control and then particularly the left fan control and see what is going on in that section of the board. So let's quickly take the board out. Already the screws has been taken out because I mean, like I said, this is coming from a repair in progress. So in the process, they replaced the fan, but that did not solve the issue. So they had to bring it without having to put the screws back. So I mean they concluded that it is a board issue, so there was no point having to put the screws in until the issue it's resolved. So the board is out. Just head over to okay. Let's open up the schematic and let's go to the board view. So we will be going to the left the left fan control section of the board. Okay, the board number is 80 that's 01700. Yeah, 01700. Okay, so this is our board. And if we flip the board to the other side, the fan control, let's see where the fan control is. So we can easily do this. We click on the fan connector. This is the left one, J6100. So if we J6100, let us open the whole the schematic and go to J6100. So 01700. Mm, I don't see it yet. Just have to type it. So it's 820-01700. Okay, there we go. Okay, now let's see what was the number again? J601 6001. So it's J6001. Okay, here we are. So it says here it says fan connector J6001. We want to go to the fan. Okay, fan underscore. So we definitely will have the 5 volts to the fan. So we want to go to so then we want to see what we have on fan underscore LT underscore PWM. We want to see what we have on fan underscore LT underscore TAC. Yeah, so Let's see where that is coming from. That is going to come from Q6000. That's going to come from Q6000. Let's see. Yeah, that's going to come from Q6000. So we have Q6000 and Q6000 and Q6005 and then Q6000 and then Q6050. So let's go to Q6000 and see what that looks like. Q6000 and Q6050, I suppose. Yeah, okay. These are the two sections we want to go to. Q6000 is here. Okay, on the other side of the board. Here on the other side of the board. So this is gonna be Q6000 here. It's Q6000. Okay, so let us see what it almost seems like we have some kind of liquid. Yeah, it looks like liquid. It looks like liquid. First thing first, let us see what we have on. Let's see what we measure at that. Let's see what we measure, and so we know that one of the four. We know that the left isn't working, but the right is working. So we will compare the signals on pin on the right side, and then compare the signals on the left. Okay, so let's see what we have on pin 1. Pin 1 is supposed to be 1.8 volt. Is that no, 5 volts? So pin 1, obviously that is present. 5 volt is present. Pin 2, let's see what we have on pin 2. We have 0.18. Okay, and then pin 4, let's see what do we have on pin 4. 1.7. And what do we have on pin 5? Pin 5 and pin 6. Start over again. Let's see what we have on pin 1. We have 5 volt. Pin 2 at 0 volt. Let's check again. 5 volt. Pin 1. Pin 2 we have 0.18 volt. Are you able to see what I'm doing from there? Yeah, but that's it. And pin 4, let's see. 4, 1.7. I mean, the way I do the measurement is I place and then I hold. So the time after you capture the hold, then you can go to see what it's. Pin 4, it's 1.7. Pin 5, let's see what we have on pin 5. Zero volt. Pin 6, 0 volt. can use the pin out easy. Okay, so 0 volt. Now let's compare. So the signal that was quite low was pin 2, which is fan LT underscore PWM. Let us now let's check that signal on. Okay, let's see if we can. If we have okay, let's see if we can get the signal on the other side of the board. Let's flip the board over. So we have a TP here where we a test card where we can measure that from. See if uh, okay. So that is supposed to be this pad here, this one. So let's see. Yeah, it's still 0.18. Okay. So let us compare that signal on the right connector, which is J6000. So the other one is J6. So J6000 is the right, and J6. Wait, J6001. Okay, J6000. It's right. Okay. Okay. Let's compare. So pin one, and let's see what we have on pin two of J6001, which is J6000 now. Okay. So we're expecting to have 5 volt on pin 1 because it says pin 1 there says 5 volt. So you can see here, yeah, pin 1 says 5 volt. So we're expecting to have 5 volt on pin 1. So let's see what we measure. 5 volt, and then pin 2 0. Okay, okay, that's I mean that's fine. I mean also because of the fact that we don't have an active fan plugged in. 177, and then okay, so let's plug the fans in and take it, see what we get with the fans plugged in. So we expect the value to change when the fans are connected. So we're talking about the values at pin 2. We're expecting the values to change at pin 2 with the fans connected. So let's check that again now. Okay. Hmm? Yeah, the fans seem to be fine. Okay, now let's see what we have at individual. Let's see pin 2. Now we get 1 point something. And then on this one, what do we get? We get 5 volt. Okay. Yeah, that's because the clip is not. Yeah. So it may well be. Let's see what we get here. 1.7 now, 5 volt, and it starts to increase also. So it may well be that the issue that we're having is the connector, and it's starting to increase again. Okay, let's replace the connector and see if we have any changes, because it's a slight there's a bit of corrosion by the connector. Let's replace it and see if that fixes the problem. Hmm. It's going to be a bit challenging. You have to take the connector from the bottom. Okay, let's see. Okay. Okay, it's installed. See the other side just to be sure we didn't do damage to the other side. Yeah, so our chip was moving from its place. Let's resolder that. Okay, let's see what chip that was, just to, in case we have a malfunction, we know where to look. What is that? E7700, that is for, okay, 2.5 volt, VPPP, good signal. Okay, let's see. Is there anything that is missing there that we should be aware of? Nothing. Okay. Now let's see if we have a different reaction.
Accessibility shortcuts, 22 items, voice guide, off.
Could actually put a, okay, so I don't have to sensorily. Let's see what reaction we get now. Okay, if it's not starting, let's see. Do we have power on the board? Yeah, let's see. This side and this side, 12.6. Okay, let's see if the board is starting. So hold the fans in place so that they don't move. Okay. If it's not starting, there could be that the chip that moved is actually not doing what it should be doing. So we may have to revisit that chip. That is if the board doesn't start. We're not really going to connect all the cables. We just need the cables that will enough cable to test the machine. Not necessarily all. Okay, battery screw in place. And let's see if we have say if it starts. We don't have fan spins. We have haptic feedback. Do we have Apple logo? No, we don't have Apple logo. So most likely this chip here, E7700 that moved something. It's definitely not in its place because we have haptic feedback on the trackpad. The machine is partially making its way into SO state, but we do not have, yeah, but the machine is not starting. Okay, so let's see what's happening on 7700. Okay, let's take it out completely and Okay, let's put it back. Okay, so that inductor we expected to have 2.5 volt at that inductor, and that is going to be regulated by E7700. So let us see if that it's happening. We have 2.5 volts there. If we don't, then we have a problem we still need to address, but if we do, then that should be fine. So I don't want the fans to do detailing. I want my multimeter to do detailing, not the fan. So see what we have. To confirm that we are in SO state. Okay, we're in SO state. What do we have here? 2.49. Yeah, that's about what we're expecting to get. So let's now connect the fan and see if we have a different scenario. Okay, this is different. Do we still have crazy fan spin? So initially what would happen is the left fan will go crazy. Um, so right now if both fans are crazy, that's expected because we don't have the trackpad connected and because of the sensor. Um, so that is expected. So let's see, do we still have one or both? I think both are actually moving at the same speed. So yeah, I think our problem is solved. So what we just need to do now is clean. Let's clean this out real quick, and yeah, and then that should be it. So and then so we clean this out and then we test based on the shell, and that should be that should be it. Okay, so we're pretty much done. However, there is this that I saw that, and I'm thinking I should clean it off before it creates a short in that section of the board, especially because it's the area of the NAND. Mm. This is not related to our problem, but this is a preventive measure to prevent the caps from shutting out in future. Okay, I'm going to wipe that. Okay. Alright, anyways. Okay, now we can connect the battery. Let's hope it starts now, and I also hope that the fan no longer overspin. Okay, so find the device is starting. Okay, device is started, and the fans. Yeah, the fan is no longer crazy. I mean, before now, the left fan would have gone crazy, but right now the fans are not. Yeah, so as you guys, nothing is coming from the fan. And then also the approach we took, which is to go to which is to focus on one of the fans only, was because both fans were not. So if both fans were spinning very loud, then we may consider it to be a possible a sensor issue. But because a particular fan was basically running so loud, so we had to draw our attention to that particular fan without having to worry about the other fan. And then what we found was the connector. So there was a bit of corrosion here at pin 2 of JCC1 6001. So what was now happening was uh, the device was not able to read the connecting pin of pin 2 of the fan. So which would mean that the SMC would which would mean that the control, which is now obviously now a T2 thing, which now means the control. So PWM, this is where the fan is able to read um, how the amount of the speed the speed at which the fan is running. Now if the machine is not able to communicate with the fan, then it would not be able to regulate it. So what was happening was the fan was getting 5 volt, and which is why it was spinning, but then there was no mode of regulation, because because of the pin 2 was corroded, and there was a partial communication there, which is why sometimes it will kind of regulate itself, and other times it will go. Most of the time, it will go crazy. So what we had to do was to first of all measure to be sure measure the voltage and the signals there, and we found similar signals, which was which are basically, so we had to compare the one that is working to the one that is not working. So we got the same signals at both. So which confirmed to us that we don't really have a board issue, but an issue with which is also, and then also supporting the fact that we saw signs of corrosion around this section. So we then decided to replace our the connector, which is J6001. And then obviously, because we had to take the connector from the back of the board, because we didn't want to melt the connector. And then what then happened in the process was U7700 was then moved from its place. So when we put U7700 back, I think what happened was the output inductor, which is L7700, had one of the pads raised, so there was no communication, and because of that, we were not getting the supposed voltage that was supposed to be regulated by 7700. But then we had to redo that, and then and yeah, now as you guys can see, we have a working fan. The fan is not, the machine is still fully functional. It's still working, and the fan it's not crazy. So this is now, so what then just this needs to be put together and finalized, and that's it. So thank you guys. I will see you guys in the next one.